So we are going to start a new chapter, that is chemical effects of electric current. Topics to be discussed in this chapter are introduction part, then we'll discuss electric current, good conductors and poor conductors of electricity, then chemical effects of electric current, and at last we'll discuss about electroplating. So chemical effects of electric current. So when we talk about electric current, what are we talking about basically? We are talking about the electricity with a type of energy which exists due to the flow of electrons. We are going to talk about electric current in detail in this lesson. A simple example, when you switch on, your bulb glows. When you switch it off, it immediately turns off. Now, what is the magic that happens inside the bulb that as soon as you switch it on, so the switch is located like somewhere else, and all you need to do is to make the bulb glow, and you just give you a lot bulb give you a lot of light. And how? Just to press a switch. It's that simple. But have you ever thought how exactly is the bulb glowing when you are switching it on? So how that happens? That happens due to electricity. Another interesting example, while you would have experienced electricity, is have you ever saw somebody or yourself trying to touch an open electrical outlet and then getting a shock? So experiencing electric shock, that's another scenario where you can actually feel the presence of electricity. So electricity provides power to various buildings, electrical devices, automobiles. If you talk about devices like camera, battery, electrical appliances, battery operated, so many devices, right? Whether you talk about computers, entire electrical appliances in your houses, fans, bulbs, everything works due to electricity. If you talk about the battery operated devices like your mobile phones, alarm clocks, or the cameras, there are so many things which are dependent on battery, because battery acts as a source of energy, source of electricity. So, in this lesson, we are going to talk about the chemical changes or the reactions which will take place when electric current is passed through an object or when electric current is passed through a solution. That's what we are going to talk about. Now, before we get into exactly that topic, let's start with the very basics of electricity. What is electric current? How it passes through a particular object, whether it can pass through all the objects or not. First, we will classify all these basics. Uh, we will clarify all these basics, and then we will try to understand the chemical changes which take place in an object when electricity passes through it. So that is the agenda of our lesson here. So what is electric current? Electric current is the flow of electric charges, and that's all. Now the question is, what are these charges? So you might not be knowing a lot about charges, but you must be knowing that a substance can be positively charged, it can be negatively charged, it can have a neutral charge. So any particle which carries a charge with it, that's called a charged particle. So we will talk about electric charge in more detail in the lesson. You will get a better idea when you discuss that at a time. So when these charged particles they move, so movement of these charged particles fuels current. And how do we actually measure it? That how much current is flowing. It's measured as the rate of flow of charge. That means how many charges have flown in a particular period of time. So, in simple words, it considers charge like, for instance, take the consider the charges like small children. So it's like you have a big playground where children are running from one end to the other. So how many children ran from one end to the other in 1 hour? So that gives you the rate of flow of children, right? So similarly here also the charges flow from one place to another, and the flow of charges constitute current. Now, how many charges had flown over a period of time? That is how we measure current. So, current is the rate of flow of charge, and the SI unit to measure current is amperes. Now, I will give a simple example to show that electric current flows through a circuit. Now, circuit is the new term here. Just look at this and you will understand what I mean by the circuit. what I mean by the electric current. All you need to do is take a bulb, take a battery, and here this is your battery, and this is your bulb. Now, if you observe the battery, you will see that the battery have two terminals, positive terminal marked here and the negative terminal marked, right? So you now in this diagram, this is the positive terminal and this is the negative terminal, right? So you connect the positive and negative terminal of the battery to the two terminals of the bulb, right? And that is how you prepare a circuit. And there is a key, or you can say switch. So this is a simple circuit to just show you that how current flows through it. So in between, you can see here is a gap. Uh, in case you think that fixing a switch here is difficult, so what you can do is, when I say that the switch is off, that means the circuit is not complete. As you can see here, gap is here, right? So that means you have not yet joined the wires. Now, as long as you do not make it complete, you do not join the wires, you do not switch it on, current will not be able to flow. So that time it means the switch is off. Now what happens when you switch it on? So as you switch it on, the circuit becomes complete. So now what happens? The current starts to flow. Current has got the path to flow. Now as soon as current starts to flow, current reaches the bulb, right? Now if the current is high enough, it's able to glow the bulb. Now you might be curious to know how the flow of current is able to glow the bulb. Actually, we'll talk about this in detail, but for your information, inside the bulb you have a filament, and as the current flows through a filament, so this filament gets heated up, and when the filament gets heated up, it glows. So that's basically how a bulb glows. So what did you see here? You saw that as soon as you switch it on, that means as soon as the circuit was complete, circuit is nothing but here a path through which charges can flow, right? Now, as I was giving you an example of children running from one end of park to the other, so they need a ground where they can run, right? They cannot run on the sky, so they need a ground. So that ground is nothing but the path for the children to run. So similarly here also, these charges also need a path to flow. So if you break the path like here, if you break the path in between, that means when you switch it off, or when the wires were not connected, so the path was not complete. So even if the charges flow till here, now how they are going to cross this empty space? So they will not be able to flow because the path is broken there. So as soon as the circuit becomes complete like this, charges get a path flow, and when the charges flow, current is formed. And due to this current, these electrical appliances which have filaments gets heated up and they glow. So here what do we see? Uh, that this entire path is termed as electric circuit. And when we talk about current, it's about the electric charges which move through this external circuit. So the charges are actually flowing through the circuit, and the flow of charge constitutes electric current that is measured in amperes.